Good morning, and thank you very much for attending this series of Pegasus Office Hours. And we are continuing our role of favorite presenter these days, Ryan Tanaka, and he will be talking about the current support for checkpointing in Pegasus and what our future plans are for 5.1. Ryan, the floor is yours.
Okay, thank you, Karen. So yeah, as Karen mentioned, today is going to be all about checkpointing, how you can get this to work in your workflows, and then also, what we plan to do to improve our support. So, in a nutshell, Pegasus provides support for transferring checkpoint files that are produced by a job, and all you need to do is specify these checkpoint files using the API when you create your workflow script. So for a job, you'd say this job has a checkpoint file, and then when that job runs, when it fails or completes, Pegasus will then make sure that those marked checkpoint files are transferred back to the staging site. That way, once the job is restarted, which could possibly be on a different compute node, Pegasus will ensure that that checkpoint file is then transferred to where that job runs, so it can resume from its most recent state. So that's what this tutorial is going to be all about. And I'm going to cover a number of things. So first, I'll talk about application checkpointing at high level. And then we'll talk about what happens when a Pegasus job actually runs. So we'll look a little bit under the hood because it's good to be aware of what goes on. Then we'll talk about how you can specify checkpoint files in your workflow generation scripts using our new Python API. After that, I'll talk about checkpointing for different application scenarios. And then to finish off, I'll just have a simple example using non-shared FS and then conclude with some of our future improvements that we're working on for checkpointing. So to start, I'm just going to import a bunch of stuff here. I'm going to use these throughout the notebook. The main one is from pegasus.api import all. It's all the classes and functions that I'll be using in the small workflow examples that I'll be running below. But to start, so application checkpointing at a high level. So checkpointing basically provides our applications with fault tolerance, and this is a very desirable property to have when we're running these long-running applications that they're performing expensive computations, and we don't want to sort of lose our work if something bad were to happen. So the general idea is that the application that's running should periodically save its state to some file so that in the event that failure occurs, then the application can restart, use that checkpoint, and continue where it left off. So we can take a look at a very simple counting application that will use checkpointing. It's going to count from 0 to 10. And if there is a checkpoint file, count that checkpoint present, it will read that in and then start from that number instead of 0. So I'm going to create a checkpoint file here. It just says 4, and we'll use that. And then I'm going to run this, and we'll see that it starts from 4, and then it will finish at 10. So at each iteration, I'm updating that checkpoint file with the current count. That way, if something were to happen, I can continue from there. And so you see that that checkpoint file exists and that it has the value of 10 in there, which was on that last iteration. So, very simple. We're basically just saving some state as we go so that we can continue where we left off. Now, what about when your Pegasus jobs run on some compute node? So this is going to be important to be aware of. That way you can get an idea of like how this whole checkpointing thing works in the context of Pegasus. So I first want to talk about 2 tools that we have in Pegasus, Pegasus Lite and Pegasus Kickstart. And so these are used when your job is run. So when your job is executed on some like compute resource, that single job is actually in and of itself a workflow that consists of 6 to 7 steps. And so these steps are run by a tool that we call Pegasus Lite, and those steps are outlined here. So first, what happens is a working directory is created. Then a check will happen to make sure that any of the tools that Pegasus needs to run the job, to do transfers, anything like that, it will make sure that this package is there. And if it's not, it will download it. Then any input data that you've specified for your job will be transferred to this working directory because your job will need them to run. Next, we'll perform integrity checks on the data. So we're going to check to see if that data was corrupted en route, because we don't want it to introduce any sort of silent errors into our program when it's running, and then our program is going to produce some output data, but then the data it was fed was bad. So we'll do some checks, and if those checks fail, then we'll fail the job. We'll retry the transfers, actually. Then after that, we can launch the executable. So this is the executable that you would have specified in your transformation catalog and said, hey, this job used this executable. And Pegasus Lite will launch that executable using the tool Pegasus Kickstart. Once your executable finishes running and Pegasus Kickstart also finishes, then your job would likely have produced some output data. And this is what you specified in your workflow script when you said job.addOutputs. That data will then be uploaded back to the staging site using one of the transfer tools. And then finally, your working directory where the job ran will all be cleaned up. So if we look at this figure right here, this is sort of like an example execution timeline of Pegasus Lite on some compute node. This is just a single job. So on the x-axis, we have time, and then on the y-axis, we have processes. Here, I only have Pegasus Lite, which is running just for simplicity. If we were to zoom into these steps, we'd see a bit more. Then on the top here, we have our file system. So this space up here just represents current working directory over the lifespan of this job. So when it starts, we create that working directory, check for the worker package, stage in the input data, which is why right here, now these files appear, the script that we're gonna run, any input files, and then a checkpoint file if there was one already created. Then this downloaded data will be validated with our integrity checks. After that, it will, the executable for our job will run via Pegasus Kickstart. And as we can see right about here, our job has produced some output. So we have output.txt appearing on our file system. And then our job's gonna finish right here. And Pegasus Lite will then make sure that that data that was created, output.txt, and also checkpoint file is staged out back to our staging site. And then once that completes, then Pegasus Lite will remove the working directory and clean things up. So there's nothing there anymore. So if we look a little bit closer at this step right here, launch compute job via Pegasus Kickstart, we can see what happens. So Pegasus Lite forks Pegasus Kickstart, which then forks the executable that you're going to run. And Pegasus Kickstart is just a wrapper program that manages and monitors the execution of the executable that you give it. In this case, it's whatever you'd specified in your job. Pegasus Kickstart it's just a command line tool, and we can execute it, just as we would any other command line tool. And I'll show that just a second. So here again, we have time on the x-axis, and on the y-axis, we have processes. So this is a zoomed in picture of this step right here. Pegasus Kickstart starts up, forks your executable that's going to run, and then Pegasus Kickstart will finish. So here I have Pegasus Kickstart as a command line tool, and I'm going to run it, and I'm going to tell it to run the program echo and with the arguments hello world, and we'll see what Pegasus Kickstart produces. So all of this output here is YAML, and this is all information about this executable as it ran. So we have things like PID, UID, user, host name, other metrics here. We can see the arguments that were passed to it. We can also see standard error and standard out. So standard out is right here, hello world, which was what we gave there. And all of this information is visible to you using our Pegasus tools if you needed to look back at this job and see what happened. So now that we know what actually happens when your Pegasus job runs with Pegasus Kickstart, Pegasus Lite and Pegasus Kickstart, then we can take a step back and now look at how do you specify a checkpoint file in your workflow generation script so that Pegasus will know that, hey, this file, for example, this one that we have right here, is a checkpoint. And so I should save it back to the staging site. And then if the job's restarted, I should also send it to where the job is running. So this step is actually very straightforward. You create your job as you would with the Python API, and then you would say .add checkpoint, and you just give it the name of, you give it a file object, which represents the checkpoint file. So I'm going to show how that works down here. But one thing to point out is that if you're using the Conjure.io data staging configuration, you do need to provide to Pegasus an initial checkpoint file. That is, one should be created, it should exist in your file system somewhere, and you need to add it to your Replica catalog. And the contents of that checkpoint file could be anything, you just need to have that file there. It's a minor inconvenience, and it's something that we're going to fix. But if you do use our non-shared FS data staging configuration, then that's not required, and you don't have to create this sort of starting checkpoint file that's sort of not even really used until it's like overwritten. But in all the following examples, I will be doing it as if we're running with a Conjure.io data staging configuration. So I'll always create an initial checkpoint file and add it to the Replica catalog. So we can look at this example here. So first, I'll create an initial checkpoint file for a counting program, which has the value 0 in it. And this here is going to be our executable. That's a Python script that we're going to run as part of our job. I'm just writing it inline right here. And then next, this is our actual workflow script using the Python API. Sorry, excuse me, just a second. And you can see here that we've defined our replica catalog, and we've added that checkpoint file that we had just written. So we're telling Pegasus, hey, this file exists here. And then here we've created our job that uses the executable count.py. And we said that it's going to use a checkpoint file, count.checkpoint. And also, we're going to want to send standard out from that job to a file called count.out. And we'll take a look at the contents of that file. And we add that job to the workflow, and then we'll plan and submit. So I've already run it just for the sake of time here, but what's happening is when you call workflow.plan, submit is equal to true. The workflow that you've defined here is going to be planned, then it's going to be submitted. That's the output from Pegasus plan right here. And if I scroll down, we have this progress bar. So that's where this step comes in. It's just going to wait and block until your workflow is finished. This wait is something we added in. It's good when you're just running small workflows and you just want to quickly print a progress bar and see how far your workflow has come. And then once it finishes, we're going to run Pegasus Statistics, which is the output that we have after right here. And if we were to take a look at the metrics that it shows, we can see that we had one task, which is this job that we created, and it was retried once, and then the workflow completed. So I forgot to add that I purposely put an error in this script so that the first time it reads a checkpoint file, it's going to throw an error so that Pegasus will see that the job fails, transfer back the checkpoint file that it's creating, and then when it restarts the job, it will use that checkpoint file again. So that's exactly what happened here, which is why we have one task. It was retried once because I purposely made it fail. It was restarted, and then it resumed where it left off. Whoops, actually, I do need to run this. So this is going to take a few minutes. Maybe I'll skip over this. Basically, the workflow is going to run, and if I were to take a look at the checkpoint file that Pegasus had transferred back, it would have the most recent number that was written during that count program. And if we were to look at the output of the count program, we'd see that it would be from the time when the application had just restarted and not the beginning portion. So that would be that. And you can go and run this on your own, and you'll see that being shown when you run these two commands right here. So that's basically how you specify a checkpoint file. It's very straightforward. You just need to add this right here, job.add checkpoints, and you say what file, and you can add more than one if you have more than one checkpoint file. So that's sort of like a simple scenario for checkpointing, but there are some things that we should consider and be aware of. So in our counting program, when we're updating the checkpoint file, we're only writing like a few bytes to the file, and that happens very quickly. The invocations to write are only writing a few bytes. And so in most cases, that won't be interrupted in such a way that we have some half-written checkpoint file. So if we look at this here, here's another example of like sort of a executable execution. So on the x-axis is time, and on the y-axis is our processes that we're running. We have Pegasus Kickstart, which starts up your executable. And it's going to read from the checkpoint file that exists first, do some computation, and it's going to do a really quick write, do some more computation, and so on and so forth. So in this case, we're doing a lot of computing and then like just a really quick write. But in many cases, the checkpoint file being written to, or the amount of data being written to the checkpoint file each time you write to it, could be a lot. And so it's likely that you could be interrupted in the middle of that write. And so we don't want to end up with this, with a corrupted or incomplete checkpoint file. Because if we have a corrupted or incomplete checkpoint file and your program reads it in again, then you need to have code in there to handle that. But also if another process needs to take that file, for example, Pegasus, we don't want it to be picking up these half-written checkpoint files. And so there's a way that we can sort of work around that, and I'll talk about that in just a second. Okay, great. So this just finished here. Let's see what we have. Okay. Yeah, so this script right here, it was going to count from 0 to 5. And so if I look at the most recent checkpoint file that was written, it has a 5 in it. If I look at the output here, actually, sorry, this one actually reused the checkpoint file. So that's why it didn't show that. But I'm not going to run it again. But if you rerun this, you'll see a different output. Okay. So I want to illustrate this scenario where we're doing a big write and our program crashes in the middle and we end up with some half-written or corrupted checkpoint file. So here I'm just going to create a 100 megabyte object in memory. And then it's just a string of characters. Then I'm going to write that to disk and see how long that takes. So here it took about a second. And if we look at the size of that file, it's 100 megabytes. So that's what we expected. Now I'm going to do the same thing here, except I'm going to start up a process that's going to start writing 100 megabytes. And halfway through the amount of time, about the amount of time that it takes to write that file, I'm going to send the Sig Kill to that process. It's going to terminate abruptly, and we'll see what happens to the pickle file that we were trying to write. So that's like a Python's serialized format. Okay, so usually this actually won't succeed and I'm able to kill it fast enough, but that didn't work. So let me increase the size of this. Uh-oh. Give me just a second here. Restart. Let me try this again. Okay, there we go. So we just have sort of a race condition here, but I got it to work. So we wrote to that big file. And if we were to look at the size of that file, sorry, this is a typo here. Even though we wanted to write a 100 megabyte file, we only have 19 megabytes in there. So we know that it was stopped in the middle. And because this is a pickle file, if we were to try to load it, we would expect to see an error because Python doesn't know how to deserialize that file because it's basically corrupted. So we don't want to end up with the same kind of situation when you're implementing checkpointing in your application, and also when Pegasus is picking up those checkpoint files. Just to dig a little bit deeper, I wanted to show that once you open a file in write mode in Python, it's going to be immediately available on the file system. And so it doesn't matter if you write like 1 byte or 2 bytes or 100 bytes. The moment you open it, it's going to be there. And so if there's another process that expects to pick up that file, when it's not completely finished, it still would see it. And so if we just take a quick look at the system calls that happen when we call open in Python internally, then we can see what flags are passed to that. And we'll see that there's this mask create, and basically it means that once you open the file, it's going to be immediately there on the file system. So this is that exact system call, and we have all of these flags here, and specifically this one. So in some cases, it might not show up, but in this example, it does. And we don't want sort of these half-written checkpoint files. We want a complete checkpoint file. So one of the solutions to get around this is when your application writes out a checkpoint file, what you can do is write to a temp file, and then immediately after do a move or os.replace in Python. Because in most cases, those things will be atomic. You do need to check with like your file system and your operating system for the move command. But at least in the documentation for Python, it says that os.replace is atomic, so that you know that that operation itself won't be interrupted. And I'll illustrate that here. So here's our same counting program, except immediately after we write the number at each iteration. Well, first we write to a temp file that I call count.checkpoint.temp. And then after that, we'll call os.replace and rename it to what our actual checkpoint file would be. So this program never reads in this temp file, it only reads in count.checkpoint. And so if something were to fail here, either no checkpoint file would exist, or an older count.checkpoint would exist, which is fine. We would still restart from somewhere in the past and not lose all of our computation. So it's doing basically the same thing here. And if we were to look at the files, that file is there, and it has our most recent value saved. So that's how you can get around not writing out half-written checkpoint files. Essentially, you still are, but you're just making sure that no other process picks up that half-written checkpoint file by renaming it and making sure you only use the file that you renamed to. So the next scenario that we want to handle is periodically saving a checkpoint file while it's being updated by a job and while the job is running. Because if there is sort of like a catastrophic failure on your node while the job is running, Pegasus will never get to the point where it can send that checkpoint file back. And so we want to sort of force that behavior. Right now, we don't have like a built-in solution to asynchronously keep saving checkpoint files and sending them back to the staging site, but we do have a solution to get around that. And so it's essentially you intentionally kill the job after some period of time, and then you restart it until it runs to completion. So when you intentionally kill the job, Pegasus Lite will get to the point where it can send the checkpoint file back to the staging site, and then it can restart the job and give it that checkpoint file again, and the job will continue where it left off. So this way, at a different location that is your staging site, at least you always have an extra copy of that checkpoint file to protect yourself against these sort of catastrophic failures. So I'll go over how to do that in the next few blocks. But first, I just want to introduce signals briefly, because this is going to kind of come into play when we make this work. So in like Unix operating systems, they have signals, and these are just sort of a means to communicate with processes, and there's different types of signals. But the general idea is that each process can have signal handlers, and when the process receives a signal, it's interrupted and performs whatever code is in that designated handler. But you do need to be careful about what you put in that handler, because you could still be interrupted again, and it gets kind of complicated. But there are two signals that we do want to be aware of here, and that's the sig term and sig kill. So sig term, if a process receives a sig term, it basically means, hey, whoever's sending this wants you to stop, but it's asking politely. So the process that this is being sent to can handle this signal. It could block it, or it could completely ignore it. And then there's a sig kill, which if a process receives this, it's going to immediately terminate. So it's a hard stop. and this sig kill is the one that I had sent in the previous example to the process that was writing the file and made it stop abruptly in the middle. So we can take a look at how you can add a sig term handler to like this count program that we have. So here I have this sample job script, which would be an executable in our workflow. But in the code, we have defined a signal handler. This is just a function, and you can put some logic in here to do certain things. Generally, it's not encouraged to put like a whole bunch of operations in here. You could print stuff, maybe set some flags to tell your program, hey, you need to stop, something like that. Then right after, you just need to register your signal handler. So you'd say signal.signal. You'd say which sig term is going to be associated with which handler, which is this one right here. And then you'd run it. So we'll see how that works. So I'm going to start up this snippet of code right here, line 1 to 26, like asynchronously in the background. I'm going to sleep for 2 seconds. Then I'm going to send it a sig term, sleep for another 2 seconds, and then I'm going to send it a sig kill. So here we start from 4, go to 5 because of this checkpoint. The parent process sends the sig term to this process running. So it prints and says, hey, I got the sig term. Then it continues where it left off. So 6, 7, and then 2 seconds later, I send it a sig kill, and then it's a hard stop. Again, if we look at what's in the checkpoint file, we'll see that it's just the most recent value that we had, because we had this snippet right here. So now that we know like what signals do and how you can add handlers into your code, we can take a look at what this whole process looks like in Pegasus when you periodically kill your job and then restart it. That way you can save the checkpoint file back to the staging site. So essentially, we'll have a value num retries, which is the maximum number of times we'll keep retrying our job. And at each retry, we're going to run that job, and we're going to start it. And then after some period of time, we can have Pegasus Kickstart send the sig term to your executable so it knows what to do. So it's sort of shut down, get ready, maybe do a rename of the checkpoint file. And then after that, it'll wait a little bit more time, and then Pegasus Kickstart will send a sig kill to that running application, which at that point, it would be a hard stop. And then Pegasus Lite can then make sure that the checkpoint file is sent back to the staging site. Your job would be restarted. And this would run over and over and over again until your application runs to completion. So the way that you do this is in your workflow script for the job for which you want to periodically save checkpoints for, you need to add 3 profiles to it. The first 2 are checkpoint.time and max wall time, which is under the Pegasus namespace. And you specify these values in minutes. Checkpoint.time is the time at which a sig term will be sent to your application. Max wall time is like an upper bound of when your application you want to kill it, although your application will actually be killed by Pegasus in the middle point of these 2, and I'll show that in the following figure. But then you also need to set number of retries properly for that job. And you would do that like this. It's under the Dagman namespace, and you set retry, and you set the value to be whatever number of retries you think it would take to make your application finish. You can also set the number of retries using properties, but this would then be applied globally to all jobs, and you might not, that might not be ideal. So here I have another example execution of your executable running, and this will illustrate all of these profiles coming into play and this whole behavior here. So again, on the x-axis, we have time, and then the y-axis, we have our kickstart in our application process and what files appear in the file system. So Pegasus Kickstart starts up, it forks your executable that you're gonna run on the file system. A checkpoint file likely would already exist. Like, let's say this has been restarted once and now the checkpoint file is created, and so it's there. And so our application is continuing where it left off. It's gonna do some computation, it's gonna write, and as we discussed, you can write to a temp file and then just rename it after. So that's what we're doing here. Do some more computation, right? And then at this time, checkpoint.time is equal to 10 minutes. Pegasus Kickstart will send a sig term to your application, at which point, if it has a handler to do anything, it will. So in this case, we'll do the rename there. And so after that, this file becomes, this checkpoint.file.temp becomes checkpoint.file. And then at the midway point in between max wall time, so in this case we set it to 20, that's when Pegasus Kickstart will send a Sig Kill to your executable to stop it. And so at this point, a full checkpoint file has been written out, so we're okay. It's just that if it were to continue running, this is, the amount that it would have run to completion, but because we killed it, we'll lose up on sort of this amount of computation that was done up until where the last checkpoint file was written to, which is fine. We're not losing all of this progress, we're just losing a tiny bit. So when this job is restarted, this whole process will happen again, except it will use a checkpoint file that we had most recently saved, and so it would continue sort of right here, basically. Or if you would think about this as progress of the job, it would continue from right here. Yeah, so basically you need to make sure that you set these values correctly. So the number of retries, when you're going to send a sig term to your application, when you want Pegasus Kickstart to send a Sig Kill to your application. So it could take a little bit of tuning. Here I have an example that's going to illustrate that. And again, this is the script that I had above that had the sig term handler in it. I'm just writing it inline so we can use it in the workflow. I also have an initial checkpoint file that we'll start with. And here I have the workflow script, which I have already, I need to run that, okay. Okay, so I'll let that run. So here I've added the initial checkpoint file to the Replica catalog, as I mentioned, because I'm running in the Condor.io data staging configuration. The Python script that I wrote up here, I'm adding it to the transformation catalog because we want our job to use that executable. Created the workflow, and I've created a count job. And here I've said, hey, use this checkpoint file, count.checkpoint. I want standard out to go to this file right here, count.out. And I've added the profiles that I mentioned above. So checkpoint.time is 1 minute, max wall time is 2 minutes. That means that Sig Kill will be sent to this executable to be stopped at 1 minute and 30 seconds. And I want this executable to be rerun at most 5 times. So then I'm running this. And also in the background, I have another process that's running just for the sake of this tutorial that will print out the contents of the checkpoint file and the standard out of this executable at the staging site. And so we'll see that these are being updated. periodically. So if I scroll down here, this is the workflow running. And in the background, I have a process that's watching the checkpoint file at the staging site. So initially, there's 0, there's nothing in there. But as we'll see, as the workflow continues, the job will be killed and then restarted. And what we expect to see is this count that checkpoint to be updated to be whatever was the most recent value that was saved to that checkpoint. And this just shows that this checkpoint file is saved back at the staging site where we want it, where we would assume it's safe. So while this runs, I just want to go over a few things to keep in mind. So when you set max wall time, that's the second profile up here, you want this value to always be greater than checkpoint.time, because the way that we have Pegasus Kickstart killing your application, it's right in the midpoint in between these two. The other thing is that it's good to get an idea of about how long it takes to write out your checkpoint file, so that you can dial in these two parameters. So if you just write a few tests, you can kind of get a rough estimate and measure. And then lastly, we set that profile dagman.retry, and this value must be large enough to allow your job to complete. So if I set dagman.retry to 1 and I tried to do this periodic checkpointing thing, and my app and checkpoint.time is set to be too short, basically no progress will be made in my application. So you need to set this value to be high enough. Okay, so the workflow had printed out some output. We can see that after some time, the checkpoint file at the staging site now has a more recent value as our count application was running. And we'll see that standard out from it shows, yes, all of these numbers are being printed out. At 1 minute in, 60 seconds, we got a sig term, which is what we expect because that's what we set in our profile. And then at 1.5 minutes, so 90 seconds, the job was killed, which is why it only got to 89 here. And then our job is restarted and it will run again until I had it run to 120. So that kind of shows, how this periodic restart saving checkpoints work. And actually, this is still running, but I'll just let that finish. Okay, so that's how you would periodically save checkpoint files with Pegasus. I'll go over a better solution that we're working on in a bit. But there's one more scenario that I do want to talk about, and this is something that we've encountered when we're looking at some machine learning applications. So sometimes your application might produce a variable number of checkpoint files, and you don't know how many are going to be generated until runtime. And so with Pegasus, you can only specify statically, like each checkpoint file in the workflow script. And so if your application does something like this, where each time it writes a checkpoint, it writes to a different file. Here we have checkpoint file 1, 2, 3, and then n. You can't really handle that. But the way that you can get around it is simply just tar them up into a single checkpoint file, which you would call a checkpoint.file, which is the one that you would specify in your workflow script. So here at this point in our sig term handler, you could tar up all the checkpoints that are there and just rename it to be this. But just be careful, because if you're compressing a large amount of files, it takes some time to complete. Okay, so that's how to handle that. If you have that sort of dynamic behavior, you can handle that by just tarring things up. And the same thing goes for like output files in a workflow. If you have a variable number of output files, you could sort of tar them up into a single one. Then you can specify it in Pegasus. Regarding using non-shared FS, so in all of the previous workflow examples, I use Condor.io. So I always created that initial checkpoint file, which is kind of an inconvenience. But if you use non-shared FS, you don't have to do that. So I have this workflow script here. Everything's sort of the same as before, except I've specified a staging site because it's non-shared FS. And I haven't specified an initial checkpoint file and added it to Replica catalog. All I did was say, this job is going to use this checkpoint file, and Pegasus will know to pick it up if it's there and not complain if it doesn't exist initially, which is great. So that pretty much covers checkpointing and how we support it with Pegasus currently. But we're working on ways to improve this process. So there's a lot of small details here that you kind of have to be aware of if you want to make Pegasus periodically save checkpoints back to the staging site. And so we want to better support that. We were doing some work with machine learning workflows, and this kind of served as the motivation to improve checkpointing in Pegasus. So in upcoming release, what we plan to do is have better support for asynchronously sending job checkpoint files during the job's runtime back to the staging site. So you don't have to do this kill and restart over and over again. We'll also have some improvements to the Python API to better support things like regex entry, so you can specify collections of checkpoint files. And what we'll do internally is tar them up and handle the transferring and untarring of those checkpoint files for you. We'll also add in configuration so that you can control how often Pegasus saves job checkpoint files on regular intervals. So right now, this is kind of controlled by what we set for checkpoint.time and max wall time, but that can be kind of tedious. And so by approaching checkpointing this way, we can treat applications more of a black box. And if you don't own the code and you can't add in signal handlers to it, it's okay. We'll just have Pegasus pick up those checkpoint files for you. So with that, that does conclude everything that I had to talk about with checkpointing in Pegasus. If you do want to find out more information about us, you can check us out at our Pegasus website. We do have a mailing list. We have a support mailing list. You can also reach out to us on Slack. We have this channel, pegasususers.slack.com. Just reach out to us for an invite, and we regularly are active in there. And then also we have a YouTube channel, Pegasus Workflow Management System. All of our workshop recordings, office hour recordings, and if we do any tutorials, they're regularly uploaded to that, and so you can rewatch things there. So that concludes everything. If you guys have any questions, I'd be happy to answer them. Okay, I think we're good. Thanks a lot for attending, guys.
Yeah, thanks a lot, Ryan, for a detailed overview of checkpointing. I think it was a great in-depth presentation. So at this moment, we can also open the floor for questions if people have about what support exists right now and what we have planned for.
I have a quick question. In future, when you add the support for Pegasus asynchronous checkpoint backup, I assume you'll want to be able to allow the user to tell Pegasus this is the moment to store this checkpoint file, or was your plan different?
Yeah, so the plan was to have the user specify an interval at which that process would regularly save the checkpoint files back to the staging site.
So there, okay.
So for example, like let's say you
so there won't
specify,
be any way to, from my fork process to say, Pegasus dot checkpointing dot store now, and it'll call like a pipe that'll tell Pegasus to move the file.
I see. No, I mean, that's an idea. I don't think we had thought of that. Like, instead of just regularly sending checkpoint files back, you want to have a way to tell Pegasus to your program. Like, let's say you own the code, so you can add in that code. It could be maybe just writing to a file that we look for. Yeah, that's a good point. I think, we'll take that into consideration.
Okay.
Do you think that's something that you might use, or like in your applications, Dino, are you doing any kind of checkpointing, or maybe plan on adding checkpointing functionality?
At the moment, the context in which I'm using Pegasus is through an application that does not do any fault tolerance, but the fault tolerance is being added as we go along. And certainly, if I could, from within my process, say Pegasus, checkpoint now, and it would, like, I don't know, write to a pipe or spawn another process that finishes up the upload. That would make my life a bit easier. But at the moment, like I said, it's not anything that I'm in dire need of.
Okay, I see. Yeah, thank you. Yeah, we'll take that into consideration. I think that's a good idea. We could have maybe like a default file that we look for that says, hey, start sending things back, or something like that. Yeah.
All right. Thank you, everyone, for attending, and I'll pause the recording.
Thanks.